think we're all getting used to Gen AI and what it can and can't do. We've worked forever as educators to try to get in the analyze, evaluate, and create state where students learn or memorize facts and then understand and apply and hopefully eventually create. But what's happening with Gen AI is it's really easy to create things like a mortgage amortization schedule or a trade-off of some analysis or net present value or whatever it might be. It's really easy to create that, but in general, do they know how to prompt? Do they know what they're getting? Do they understand what it is they're trying to do? So I've made this new website called Richly Assess, and Richly Assess is a companion to Richly Analytic, and it really just gets at, hey, the world has changed and now we need to up our game and not just do multiple choice questions they can answer with prompts, but now see if they really understand the underlying context and underlying knowledge that they need. And so as I've thought about it, there's really three ways to assess this knowledge. The first is kind of what we've always done, but homework, but allowing prompts. So I'm going to give you some examples here, and you can see some of these you could answer with prompts, which is fine. I believe that students have access to GenAI before class. They have access to GenAI after class. So we might as well use GenAI in class is my belief. And so with some homework, we allow those prompts. Let them learn how to prompt. Let them learn how to answer questions they might have. And I believe it is how students learn these days. I personally would have loved to learn calculus using GenAI, because what I would have done is just done example after example after example and just had asked it to explain what it's doing, right? And so it might be like old days where, maybe you took exams when I did, but you have to provide a solution, but to prove it's yours, that you didn't just copy off the guy next to you, you got to show your work. And that's where we're trying to get to. You need a solution, but we need to somehow show that work. It also works well for an oral examination. And I know we have big sections, big classes, but somehow, how can we just actually ask them what they've got? And there's increasingly ways to do this actually using AI. And I think that technology is going to improve, and as well as our knowledge of how to use it, where it's not such a time sink, but that students are on the line to ask if they really understand it. The third is via exam. And that's, after they've learned a concept, now can we ask and see if they really understand what they're doing? So I'm going to provide a couple examples here. The first one is depreciation. And this one's easy because it's just one prompt. So create a grid showing different rates of annual depreciation based on a 10-year asset and use of straight line and double decline balance depreciation. So that was the only prompt that was given. Here's the output, and here are the assessment questions. And so as you look at the Richly Analytic website, again, that's richlyanalytic.wordpress.com. Sorry, it is richlyassess.wordpress.com. And there I have 20, 30 examples of this where I provide a prompt, I have an output, and then I have some assessment questions. So given this, I'll ask, what is the salvage value? Well, in this case, no salvage value was given. I see down here that it's a 10-year asset, and essentially there's nothing associated with a salvage value. Now, what is useful life? Well, I could get that from the prompt. This is a 10-year asset, and so it doesn't look like I have all 10 years. If I just looked at this, they'd just see 6 and maybe not answer it correctly, and so they've got to kind of know what they're doing. So in year 3, we say, which choice of depreciation gives the highest net income? And so since these are expenses, I'm going to see that straight line has a lower expense, at least in year 3, than does double declining balance. So I've got to recognize these are expenses, and I've got to deduct expenses to get to net income. So the correct answer there would be number 3, but students would have to think through that and understand what's going on here in both cases. In question 4, in this scenario, would depreciation expense be considered to be an independent or a dependent variable? So depreciation is dependent on what? Well, depreciation expense is the dependent variable, and I hope as we do more and more regressions and even more Gen AI, we're recognizing the relationship and even the way to call out in a regression context or even a correlation context what the relationship would be. But clearly, annual depreciation or depreciation expense would be a dependent variable. And it depends on, and you can see question 5 here. Okay, what factors does it depend on? Well, here we can quickly see its useful life, right? Its salvage value. It's the amount of the starting asset. I mean, what are we depreciation? And fourth would be our depreciation method. So if they can understand that, and I think if they understood all these parts, that I would say, they're well along the way to understanding depreciation. And even if I gave them this early on and I provide this as part of homework and they learn the parts, even using prompt, then I can say, I'm going to ask a very similar question on an exam and just change it up a little bit. And so that's one idea. The next, I thought another appropriate example would be to compare cost savings from electric vehicles versus internal combustion engines. Might be somewhere interested. So we have a set of prompts again. We have the GenAI output, and then we have an assessment based on that. And so I'm one that always likes to use sensitivity analysis, and let's see how we did it here. But if I had an electric vehicle that averaged 4.01 miles per kilowatt hour, and the cost per kilowatt hour is 8 cents. Okay, so here I'm saying how efficient are we on the basis that works for electric vehicles, and then what's the cost. And in comparison, here's an internal combustion engine that averages 30 miles per gallon, and the cost for each gallon of gas is $3.50. I also give it a little more context. I plan on driving each car 15,000 miles. Electric vehicles, since they cost more than internal combustion engine cars, how much more am I willing to pay? So what I'm trying to do is calculate the fuel savings. Okay, so it will calculate that, and then I'll say, hey, give me a heat map where the average electric vehicle averages between 2.5 and 4.5 miles per kilowatt hour. You see we started at 4. And the price of gas, kind of on the other side, is $2.50 to $4.25. And so you can see, so then I ask it to do a heat map, but you can see here's the gas price, here's the efficiency miles per kilowatt hour for electric vehicles, and I can kind of see. I can also see my base case scenario. So this, after prompt 3, this would be the answer. This looks like 72.50. But I can see, hey, cost of prices going up or going down. And as you can see here, and the cost per kilowatt hour, or the efficiency of the electric vehicle, is changing. Not very efficient, very efficient. And so based on that, there are some savings. And so I'd like students to kind of understand that trade-off. And the next actual slide here, 121, builds off the same thing, but now I'm just getting the present value. So if this says, hey, you should be willing to pay $7,250 more for the car because of that fuel savings, but now in present value, I look at that same cell and that goes to 6108. And so talking about, present value. So then there's a set of questions associated with it. How many miles am I going to drive? 20,000 miles instead of 15,000 miles. If the gas average is something different or efficiency is different, now I'm going to look on the grid and see where it fits. But what I'm doing is I'm doing a trade-off here. And then I'm asking students about it. Did they really understand it? And then I'm going a little bit further and saying, hey, let's look at present value, because that should be more appropriate. Because if I don't get that savings for 5 years, then, maybe, the present value of that discounted would be much smaller. And then I kind of ask open-endedly, what other potential financial or non-financial characteristics? So I don't know that you could show this up kind of without having covered it in class. But certainly it's a way of showing prompts, showing the output, and then having assessment questions. So I kind of provide a set of those. You can see as we go through here, there's a set of questions. So here's net present value, Anscombe's quartet, which is kind of a visualization issue, journal entries and trial balance, lower cost of net realizable value for inventory. So you can see there's a set of possible assessments that could be used.